So we like to play with the format from time to time. I was thinking we'd try something new. Can you read that little blurb of text I sent you, and then from there we'll start to break down your thoughts on it.
It says, you know what this word means.
Well, what's the word?
So this episode's topic is attention. You know what this word means, but it's now being used in a very special way in machine learning. Attention mechanisms are being introduced to learning algorithms, and it's surprisingly good results. It's having surprisingly good results. This is especially true in natural language processing. Attention mechanisms make it possible for machine learning to find solutions that are able to identify key pieces of information to retain, which might be important later in being able to correctly understand something or make an intelligent choice. Well, if that isn't a run-on sentence, I don't know what is.
Hey, you get long sentences when you make good formal definitions. Well, what is your take of what you've just read? Give me some feedback.
I don't know. I'm trying to go through and find out where the commas and new periods should be.
All right, well, when you've done that, break down the pieces for me.
Attention mechanisms make it possible for machine learning to find solutions.
Yes, that's the key germ of wisdom here, absolutely.
Identify. Something about identifying key pieces of information.
Do you know what I don't know why you would. This is rather rhetorical, but do you know what an attention mechanism is?
No, what is it?
All right, so let's break that down. Machine learning has this quality that I would describe as stateless, and I'm sure many people will take a great offense to the way I'm about to describe it, but it is what it is. Most of the time, you feed in a set of inputs, and you get a set of outputs, and the algorithm, the machine learning part that's trying to figure out how to map from inputs to outputs, it doesn't often take a sequence into consideration. Now, of course, it can. In the past, we've talked about things like RNNs and the LSTM on this show and stuff like that, but these are specially built mechanisms. They're sort of ways of carrying over some context from the past into the present so that the machine learning algorithm isn't totally blind. So I thought of a way maybe I could help you appreciate this in your real life. I'm going to play a clip for you right now. Let me adjust my mic. And what I want to know is, can you tell me what this clip is about? Okay, here it comes.
Well, you can't count on it.
Yeah, that's exactly right.
It said something like, I was saying you can't count on it, and then you said, that's exactly right.
So what is it that you can't count on?
That's so funny. I don't remember what I was talking about.
But I mean, you said it. You should be accountable for your words. Like what?
Yeah, but it's
what
so
is it?
out of context. How am I supposed to remember? It could be a long time
Because
ago.
it was slightly under 955 days ago that we recorded that episode about Paxos. So why can't you remember?
Over 900 days? That means 3 years ago.
Weren't you paying attention when we recorded that episode?
I was, but not that much attention, I guess.
Right. So here is why I want to stress we're going to use the word attention differently. You may have paid attention that day, but not committed it to long-term memory, or at least that's the computer scientist me wants to describe it that way. So attention is more about in the moment. Now, what makes it hard for you to know what this clip is about?
Well, you can't count on it.
What can't you count on? How come you don't know?
I don't know. It was so long ago. You cut off what in the world we're talking about.
Oh, I cut something off. Okay, let me back it up 3 seconds, and I'll play it. By the way, this is only 48 seconds into the podcast, and the first 22 seconds are the introduction, so it's not like we got far into the conversation here, but I'll back it up 3 seconds so you can listen.
So what would it mean for the network to be unreliable?
Well, you can't count on it.
Any thoughts now?
Well, you said network and reliability, so we're talking about what it means to be unreliable.
So what can't you count on?
Networks that are unreliable.
Yeah, now, why didn't you know that earlier?
Because you didn't back up far enough.
Yeah, so you had to remember a whole 3 seconds of audio to have the context for what that means. And that's attention. I mean, you would say that the human being has to pay attention, so it does work in kind of like the colloquial sense, but that is exactly why it's a good term to describe what machine learning people are trying to do. That is a key feature of natural language processing and natural language understanding. So we have to find some way, some mechanism by which machine learning can emulate that same behavior.
You have to have some way to analyze it. Is that what you're saying?
I said emulate, and I want to stick to that word because, I often mention to you a lot the word anthropomorphizing, more maybe in the context of our parrot Yoshi, but it comes up a lot in AI too, that sometimes machines will do things in the same manner that humans do it, but other times they can do it in a totally different manner. And maybe that way is even better. It's just different, solving the same problem in another way. It isn't that for sure machine learning has to do attention the way the human brain does it, but it definitely is going to need some attention mechanism, some way to remember the context and remember important things in a sentence, but forget things that don't matter so much. For example, what was the first word I said when I started this show with you?
This one? I don't remember.
Why not? Haven't you been paying attention?
Well, like you said, it's different than committing to memory.
All right, well, what was unreliable earlier?
The networks.
All right, so you remember that, but you can't remember the first word I said? Why not?
It's different.
How is it different?
It's different context.
Context. Tell me more.
Context leads me to believe whatever the first word is that you said. Well, first of all, you never tell me when you're recording. So I don't know what you mean by first word. So number one, you just start recording. So you didn't say anything.
Well, the listeners, they'll hear the official edit point. So to them, you will sound foolish.
Well, there you go. Nobody knows except the listener. Anyway, so you don't even have a starting point. Number two, if you had said something like supercalifragilisticexpialidocious, I probably would have remembered. So what it tells me is either whatever the first word you said was unimportant, or two, just not memorable.
Yes, I think that's exactly right. I mean, maybe I could take offense to that, but more or less that's exactly right. And that's why you don't have it exactly in memory. Datadog is a monitoring platform for cloud-scale applications and architectures. Datadog has one of the largest infrastructure performance data sets in the world, and they use that to drive their machine learning-based algorithmic models for anomaly detection, outlier detection, and forecasting to automatically predict and identify performance issues in their customers' environments. With 250-plus integrations available, Datadog will plug easily into your existing technology stack. You'll get out-of-the-box dashboards, those outlier and anomaly detection and forecasting machine learning-based systems I'd mentioned earlier, and all the enterprise-grade features as well if that's what your organization needs. But applications of all scales and sizes can use Datadog to monitor, troubleshoot, and optimize their application performance. You can get 2 weeks free to try it out by visiting DTDG, like Datadog with no vowels, dtdg.co/dataskeptic. One more time, start your 2-week free trial at dtdg.co/dataskeptic. What's really curious and amazing about attention is the way the human brain filters the things you need to know and the things you don't need to know, because you can't remember too much. There's some weird psychological heuristic about you can remember 7 things at once. Have you heard that?
No, I never heard of that, but tell me more.
Yeah, I don't know. I've been meaning to look more into this because I'm not sure if it's true, but it might be. I don't mean to cast doubt on it either, but there's just an idea that you can only hold so many things in your memory at once. For example, like if I went and gave you a bunch of details about let's say some real estate property, I was like this many bedrooms, this much taxes, this much this, and I gave you like 20 numbers. It's unlikely you'd remember all of them. Maybe you'd remember the ones that you're interested in, such as like the tax rate or the monthly payment or something like that. And if later I was like, how many crown molding things does it have? And you're like, I don't know. I'd be like, it's 57. Why don't you know? Because you filtered that detail. You didn't think that was relevant.
All right. So it was irrelevant, is what we're saying, what you said.
As much as it's kind of obvious that attention is important for natural language processing and understanding, machine learning out of the box, it's sort of non-trivial how you do that. And this has been a source of great research and great progress in recent years, is how do we make machines that not only, have this ability to have attention, to take details from earlier, but also kind of learn the model or the mechanism for which things are actually important. So maybe it would be helpful if I described a little bit more about how machine learning is sort of the plain vanilla versions are kind of limited. So take something like maybe predicting the price of a house, since we're on real estate here. We talked about this before. Obviously, you'd have features like how many bedrooms, the price per square foot, whether or not it's a good school system, variables like that. And all of these things, you can do very simple regressions to try and make a good prediction. If you come up with a nice model that makes good pricing predictions, and you want to predict a new property, you have to give it all the same values. You can't say, well, I don't want to tell you the bathrooms this time. I want to tell you how many coconut trees it has. The model's expecting a fixed input.
Okay, the model is. Yes.
Fixed input is kind of incompatible with the idea of attention, because the sort of naive way you would do a fixed input in natural language is make the last n words into features. So let's say you want to have like 30 features. You just look at the last 30 words of some document, which is actually surprisingly going to do very good for a lot of things. You can get decent accuracy on a lot of problems just looking back 30 words. But if you really want the full context the way our brains are used to experiencing it, you have to look back more than 30 words. And it's not about how many words can we look back. That's not the benchmark that we're interested in. We're interested in smarter ways of doing it. So you still have a limited input vector, but you come up with an attention mechanism. That's a way the machine learns to recognize certain things from the past and kind of carry them forward.
Okay, so you're saying recognize it and then carry it forward. But you're asking is how can we do it efficiently?
Yeah, and I'm being a little vague. I'm not getting into the methodologies today because you and I are going to do a couple follow-up episodes where we talk about some of the breakthroughs. There's 3 or 4 of these actually that kind of have advanced this technique. But the key I wanted to get out of this episode, titled Attention, is just, what it means to have attention, at least in a machine learning context. Just some basic statistical technique like TF-IDF that probably is totally insufficient for us to figure out, hey, what are the words I need to pay attention to? So I can't just rely on the most recent 10 words of a document. Even though those 10 words are extremely important, I definitely need those. I also need something else from earlier. And what that something else is and how you encode it and how you get a machine to figure out how to memorize it or keep it in memory or keep attention on it, those are the topics you and I will cover in the next couple episodes we talk.
Well, attention is in the moment, paying attention. But I mean, I guess when you say identifying something that's important, that's different than attention, right?
I think it's part of it because you first have to identify an important thing in order to know you need to remember it.
Yeah, I mean, it makes sense. I could definitely see that, but I still feel like, I mean, if you think of a baby, the baby's probably paying attention. But then if you were actually able to ask a baby, like, what did you see? What did you have? Like, there was a lot of language missing. There's a lot of comprehension missing. So I still feel like there's like a foundational thing still needed. But do you think like identifying what's important out of what someone says, that takes experience, don't you think? Like life experience.
Well, I would hesitate to use the word life because that kind of colors and anthropomorphizes it. But you're right. It does take some sort of experience. You have to have sufficient training data or something besides. In the case of a baby, I mean, the baby hasn't fully booted up yet. It still has a lot of software to install, and that's kind of like it doesn't even have language yet. So it's a more rudimentary system. In I know I'm being a little crass here, but eventually that baby will have a lot of training data, and it'll bring a lot of context to the table, kind of in the same way that modern machine learning through embeddings brings context to the table. So you can start from a pre-trained embedding, like the word-to-vec algorithm we've covered on the show, or Elmo that I recently had an interview about, or BERT, things like, that have come since Elmo like that. In a sort of analogous way to your baby example, that's a way of providing a sort of life experience that bootstraps the whole process. Well, let's look forward to the next time you and I talk when we'll get into things like neuro-Turing machines and different ways that attention mechanisms are done.
I look forward to knowing what in the world a neuro-Turing machine is. I can't wait.
Oh, I'm so glad you said that because every one of those words gets me excited when you put them all together.
Well, that's why we're together.
Yeah. All right. Well, until next time then, thanks as always for joining me.
Thank
Linda.
you.